Okay, the reason I put this talk together once was simply that you would not think that Erlang was something that's just fell from the skies, sort of, where did it come from? But that's quite a long story before it. I think a lot of you probably have a sort of functional or Lisp programming background, but there's quite a large other computer science tradition. So, how do? Okay. Well, once upon a time, if you are building just a very simple system with a very little computer, the way this would be programmed if it was running in real time is essentially that different people would write each their little programs, and then you would have essentially some sort of cyclic monitor that called them or called each program once a second, or and then if they needed, these programs needed to communicate, well, that would be essentially common data. And because only one program at the time was running, there would be no problems in the interference. But the first generations of computer-controlled telephony systems were actually designed in assembler. And people had problems, of course, they didn't know very much about software systems architecture. And also there would be terrible problems where one program could sort of overwrite data in another program's data area, etc. But in the early 1970s, Ericsson released this AXC system, which became hugely successful, sold to about 110 different countries. And it was programmed in a rather, you would say, rather simple high-level language. But the cleverness wasn't what you saw immediately. It was that each program could only communicate with other programs by sending messages, and they could not meddle with each other's data. And there were also other clever ideas, like there were two parallel processors, and you could switch over from one to another, and in that way update software without stopping running. And here I will mention Niklas Wirth, and he has had a huge impact on program language developments and also on what we did at Ericsson. And you can see some of the stuff. I mean, his idea, modules, well, that's design units, processes, but they would be a sort of syntactic concept that's for handling parallel activities, and then processes had to communicate. And then he also invented PL-type languages. I don't know if you know about them, but that's one of the most fun types of languages there are. So I took part in creating this PL163. It was the language, it was a PL language, but that meant a sort of high-level assembler. I mean, it had if statements, case statements, etc. But the variables were actually registers and memory positions. So you would have statements like, if register 2 equal 100, then blah, 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 else, blah, blah. So you could write structured programming and yet be very efficient. And in this case, we even created, we didn't know that even the term scheduler, but there was a scheduler. The processes could communicate by sending some little messages, and then they would be, when they were waiting for a message, they would be held on a queue. So and this was used for some systems. I know that this is where I met Mike Williams, because he was involved in creating some military telephony system using this language. He was very cross with me first because he was used to the old job table systems. Then early 1970s, Niklas Wirth created Modula, which had modules, processes, and process communication through some weird system called so interface modules. It would look like this. Different processes would sort of call the procedures in this interface module, and only one could be executing. And here there was a few of us from Ericsson in 1976. We went to Zürich Eidgenössische Technische Hochschule, where Niklas Wirth was a professor. And that's me presenting a language. I've forgotten everything about it except the name. The idea it would have very colorful manuals, Pascal for telecom. And and this language, I don't think any of you have heard of, but this was a great effort by the CCITT in Geneva that is sort of coordinating standardization in telecom systems. They decided, yes, we have to create a programming language that everybody can use and we can exchange software. So here you see the effect of Wirth. There are modules, there are processes, but then there's a question about process communication. There are three methods: regions, critical regions, buffers, and there are signals. And you might wonder, this seems very strange, and there's a very simple answer. But here, this is out of a book about CHIL and Ada and other languages. And it explains simply that the situation was not clear at that time which method of communication would be the best. So the answer was this. Philips wanted regions, ITT wanted buffers, and Ericsson wanted signals. But of course, you can't, I mean, if we're going to exchange software, you can't build a system with a combination of all of these. I mean, you have to have one method, otherwise it becomes very complicated. So this meant that sometime 1999 or so, CHIL was no longer maintained. But anyhow, we created at Ericsson something we call Erypascal, and it contained modules, processes, and there was process communication using signals. This was actually like a subset of CHIL, but it was implemented on USD Pascal. And essentially, each process would be like a Pascal program. And somehow we created a runtime system implementing the signals. This you must have heard of in the United States. Ada was supposed to be the standard language for defense applications. And there were several proposals, and they were cut down to 4 different ones and then into one. And it has packages, but that was their term for modules, and has tasks, that's their term for processes. And then they invented a new way of process communication called rendezvous. It was like this. One task that wanted to communicate with another would sort of call a procedure in the other task and then wait until it gets suspended until it gets the answer back. I mean, this is a sort of, what do you say? I mean, offline invention. I mean, if you wanted to do message passing, you would actually have to have a buffer task. So one task interfaces and passes some data, and a bit later, the other task makes a call like this to get the answer back. I mean, and this was pretty far-fetched. So the strange thing is, why was process process communication so complicated? Well, the answer is that a lot of these people, they had a background in sequential programming. They were used to writing Pascal programs, and then somebody says, oh, these programs should actually talk to each other. And well, oh dear, how do you do that? And what they knew of that was like Fortran Common. That at sometime there was sort of inventions of signals and so on to coordinate which one was sort of talking to each other. But the thing is that suppose you start with an application that you have, where you have various units. You have, I mean, different, here's a telephone switch, here the telephone, you have different units that do exist in parallel. I mean, that's your thinking from the beginning. Then you have a different mindset rather than if you start with sequential programming. Anyhow, one of the good things with Erypascal is that we got such sort of credibility with Ericsson management that the crowd of us could actually go to the director of technology in the big Ericsson corporation and propose the creation of a computer science lab. Well, at that time, Ericsson had quite a lot of money because of the success of AXE, but they had quite a number of labs. They had labs for fiber optics, soldering, chemistry labs, etc. But the whole idea that you could sort of do experimental work with programming, that was new. And the strange thing is that we were actually allowed to start. I should say also that in parallel with all of this, we had been doing work, actually developing applications in Lisp and also started to experiment with Prolog. So when we started, we got the mission. This is very important to realize. Erlang was never a skunk work. It was officially supported from top Ericsson management. And our mission, I mean, was create a software technology for future telecom systems. I mean, we must have been rather stuck up, self-confident to suggest such a thing. But I mean, yes, Francesco has seen the document. I mean, this was our mission, and we got it signed by our management. And then the first thing we did was actually to create a real laboratory environment for software experimentation. The telephone switch is this thing in the middle, which has various sort of units, tone senders, tone receivers, etc. But then there's a connection to a VAX computer from digital equipment, which could be sort of programmed in all sorts of normal ways. So actually, instead of having the sort of the onboard computer for this switch, we had got it replaced by the VAX, which we could then program using any sort of technology, which we did. We sort of programmed this thing in all sorts of languages that we could put our hands on. And we thought that, okay, now we'll see what's the truth, which is the best way, how should we do this programming. And this is a text from Mike. The problem is simply that we learned a lot, but we didn't get to this final conclusion. I mean, future might suggested systems might be built using a lot of different technologies, etc., etc. So, I mean, we were allowed to create a lab, set up a lab environment. We ran out a lot of experiments, and we didn't come to a conclusion. Still confused, but at a higher level. On the other hand, we had learned a lot. So then it was about time to sort of go back to first principles and start again. one of the good things is that Mike knew a crowd at another department were interested in prototyping actually new telecom systems architecture. So we had a user group. Well, I mean, if you imagine, I was actually boss of this crowd. I mean, how do you sort of manage a person like Joe? The answer is that Joe was a very friendly sort of chap. You put him in connection with a user, and he will be. He'll not do what I tell him, but he will be interested in helping the users. So this is the original Erlang design team, and well, they're a bit younger looking then. And what happened in the end is that we did not. The idea was not to invent a new programming language, and we were a little bit aware. We thought that perhaps languages are created by international committees like CHIL or Ada. But anyhow, that's what happened. Essentially, it's a combination of the concurrent programming that I've been describing with sort of symbolic programming like Lisp, Prolog, Miranda, etc. And then combined with some clever ideas for fault handling. So so this group started actually creating a language, and somehow we have to invent a name. Well, like Erypascal. What is it? Erylisp, or what is it? Perhaps it would be Erlang. And then, aha, we got. There's a term Erlang. I mean, if you're sort of in the telecoms or data communications world, you know, I mean, Erlang is a sort of is a measure. It's just like I mean, Pascal is a unit, and also it could sound like Ericsson language. It was, I mean, it's a silly pun, but I mean, it's a good name. So, and it's a well-known name. So, okay, we laughed a couple of days for it and then decided on. So that was the background. There had been things like Erypascal before, and then Erlang, well, Pascal, Ada, Occam are also named after mathematicians. So, I mean, we're keeping into a great tradition. And also, by now, I think it was in 1984 that Ericsson decided to modernize their visual image and created a new logo, which meant that the old logo, that was free for reuse, which we did. Ta-da! I mean, so if you wonder, where did the squiggly Erlang come from? Well, it was a very faithful copying of this Ericsson logo. The interesting thing is that this program that I've been telling you can be followed in CS Lab publications. Here we presented all of these language experiments were presented at the conference 1986. And then that was followed when we restarted the whole project, when Joe joined the team and so. Then you get this sort of papers, phoning philosopher's problem or using Prolog for rapid prototyping. That was actually reporting from ongoing experiments. But here, then Erlang was sort of stable enough that it could be presented, and this was no mean conference, huge conference, which lasted a week, and there was one day of technical visits. People were sort of sent around in buses visiting various installations at Ericsson, and they also came to our lab, and we had created a demo to show Erlang and how we could do the program, etc. And then I think Joe was the one who scripted this, and then he hit on the idea that this demo was so clever, so let's sort of preserve it for future. Let's put it on videotape, and that is Erlang the movie. That's a background to it. It was what we showed for these technical visits. We actually ran it 8 times in one day, so we're pretty tired of. So what happened then? Well, these types of papers, they presented sort of very, very much prototypes using Erlang. This was, Erlang was a prototype which was used for developing a lot of very clever prototypes. But then, now this is for real. That was when Bogdan Hausman joined the team from the Swedish Institute of Computer Science, where he had been working on implementations of Prolog. An efficient implementation of Erlang, and now it's getting serious. It's not a prototype. It's getting to become a useful tool for building real products. And I mentioned Erypascal a couple of times because, of course, I was very much responsible for it. But the Erypascal manual, that was an internal Ericsson document that's as boring as all other documents. This is typical Joe. No, let's write the book and have it printed by Prentice Hall. I mean, this is like, I mean, he moved Erlang up to a sort of higher division. Instead of in the Swedish football league, it's La Liga or Champions League or something. That's where we were playing. And this is also sort of typical of the stuff that Joe was doing. And here, well, 3 wise guys, Joe, Robert, Mike. We had a very early communication with Belcor and were invited there to go give an Erlang course and discuss projects. So that concludes my presentation here. So if you're still awake, so thank you.
A wonderful, wonderful trip down memory lane, Bjarne. Thank you so much. Are you going to show us Erlang the movie?
No, well, I haven't got it on my computer. You've all got it.
Let's see. Oh, they've disabled the polls. Okay, we should have had a poll, to ask. So we have one question from Duncan McGregor. We have 2 questions from Duncan McGregor, a request and a question. Now, Duncan, why do you go ahead with your first request, and then you can unmute yourself, and then I've got some comments for Bjarne as well, but we can do that whilst Bjarne has fulfilled your request.
Great, thanks. Yeah, for some reason Zoom is not letting me start my video, so apologies.
What t-shirt are you wearing?
Actually, under my wool Pendleton shirt, I'm wearing an LFE t-shirt.
An LFE t-shirt. Viva la LFE, great.
That's right. So, yeah, so the request is, could you take us back to that slide with those 3 young whippersnappers, the separate picture earlier on, not the later one, where they each have their own separate picture.
Oh,
and
which picture?
Yeah, further back, the one further back.
Yeah. With the 3 languages, or no?
No, the three Mike, Joe, and Robert.
Okay.
As separate pictures.
I think.
Yeah, that's it right there.
Okay.
I love it. Oh
Okay.
my God.
Yeah. Okay. So I've got a point, and then Duncan, we'll get you on as well. Now, you've got a question as well. I'm surprised, Bjarne, you don't mention small talk, and this is where in the story, I'd go in and I'd ask Robert, how did small talk influence her? Like, oh, not at all. And then I'd go in and ask Joe, Joe, how did small talk influence her? Like, oh, a lot, he would describe. And so it just shows how different people contribute to different parts to Erlang. And if we look at small talk, whilst it's no language, not a concurrent language, it's got objects don't share memory, and objects communicate with each other through message passing, which I think our world sounds very, very familiar. What's your view on it?
Look, the thing is that there are a lot of things that I have not mentioned, and that is that at the computer science lab, we were doing work with a lot of technologies. And for one thing, one reason that we were allowed to buy a VAX computer in the lab, because you remember then at that time there was a big data department, and they didn't like computers in other places except their big, huge IBM 360 computer. So, and they were very wary about digital equipment computers coming in. So can you guess why we were allowed to buy a VAX computer? It was because we were going to use something terribly weird called Unix. Oh. So I mean, we were sort of we were prototyping Unix, and I think that we got the second first Sun workstation that came to Sweden. And we had people, one chap working with expert systems technology. And so I mean, yes, we even got a small talk computer. So, okay. I cut out a lot of other stuff. I mean, we were supposed to help other people introduce new technology. And this was like one branch. There were other branches in lab as well. Yeah. And don't be surprised if you get different stories. I wrote this paper in order to give my side.
I need to blog about the story about the Lisp machine as well, which got ordered. And the Lisp doesn't appear anywhere in any of the historical papers, as far as I'm aware, but you did order a Lisp machine, which was delayed a few weeks, and I believe that was more or less the time when you decided to actually go in and invent Erlang, because you had nothing better to do, if I recall.
But Lisp actually played an important part, because I had used Lisp to write some application programs. Amongst one of them was actually an interpreter for this Plex programming language, and there was a huge project going on to build this, and I sort of outrun them in a couple of months single-handed, because I had Lisp. So that that's why there were two inputs to the Erlang development. And one is Lisp and functional language experience, and the other one is the concurrent experience.
Wasn't the Lisp, wasn't the Lisp machine also used for doing a project on trying to analyze errors that came from the switch and do something sensible with detecting errors and trying to interpret errors? I remember
very possibly
it was there, but yeah, no. No, the reasons that Joe says it's Smalltalk was influential because he was the one playing with Smalltalk. Mm-hmm. That's why for it. But so I knew of Smalltalk, and I probably wrote about 10 lines of it, but that's about it, right? And it didn't have concurrency.
Exactly.
And the send was just fake. It was just a function call, right? Oh, no, can't do that. Of course, it didn't influence
But I think the good thing was, I mean, Mike had all of this knowledge from this telecoms programming. I mean, about use as a user. And Joe came from the Swedish Space Corporation, and he hadn't a clue. But he was sort of, but that meant in a way that he was fresh in his mind. He could look at things in a new way. So that was very good. It was a combination of Joe and Mike in that way. I mean, when Mike would come with modules, processes, messages, blah, blah, blah.
Well,
and Joe, I think Joe was actually primarily a problem solver.
Yeah, and I think I usually refer to Joe as, oh, he's the one who wrote the operating system for the Viking satellite, which was the first satellite Sweden shipped off, sent off into space. And that was one piece of software which was not allowed to crash, because if the operating system for the satellite crashed, the satellite would crash. And the satellite eventually did come down, but it was not because of a software fault. Duncan, now I just saw we've got Robert Verding here. So Duncan, you had a follow-up question.
That's right, and
Yes.
Robert can confirm. Bjarne, did you realize that Robert used the second logo that you showed, the Erlang LM one, as the basis for the first LFE logo?
Yeah, that was a joke. That was a bit of fun. No, I'm not going to show it. I can find it if you want, but I hadn't planned to show it. But yes, it was there.
LD, beautiful language, which for quite some time had a much nicer website than the Erlang official website. So yeah, thanks to you, Duncan. Great. Rob, if you look it up, great. Yeah, we can let you share the screen. It's up to you. We've got another question.
If I find it, I'll do it. If I find it, I'll do it.
Yeah, let us know whilst you look for it. We've got another question from, okay, it's an acronym, FONS, I believe. It's a really good question. If you're there, FONS, if you want to unmute yourself.
Yeah.
Great.
Yeah.
Hi there.
Hi. I mean, for a long time, we have been like repeating mistakes or have been like patching technologies to cover bad designs from the past. And I think Erlang ecosystem is doing a great job spreading knowledge for creating like good modern systems. But in terms of technology, systems, and especially concurrency, what is like the biggest problem you think we haven't solved yet in terms of systems design?
Oh, I should say, I had an idea from the beginning. I thought there were sort of several successive programming language generations. I mean, you have machine code, assembler, then you would have higher level languages, and then we would come to functional programming, and then we would sort of continue upwards. Well, it hasn't quite happened like that. It's quite interesting. I mean, after all, in hardware, I mean, you have generations after generations, but it's not quite happened like that in software. I mean, people write a lot of C, which is roughly like Fortran once upon a time. So I thought we would sort of by now have moved on to some sort of AI type programming.
Yeah, I couldn't trust the AI. I found the picture, by the way. It's only a small one, but
if you want to share your screen, yeah, go ahead.
Yeah.
Basha needs to give you...
Will I stop share?
Yeah.
Okay, let's see. I still need to. Someone has to admit me. Let me share. The host has to let me share. Yeah.
Okay.
No, I think I did it. Let's see.
Basha's the boss here, yeah.
Let's see. Screen one, entire screen, application window. Try this one. How's that?
Okay. Cool.
Yeah, that's it, right? That's It's
Okay.
it's the Erlang Bjarne took from Ericsson with the L and the F. Well, yes, that's display Erlang, of course.
That is why an Erlang developer should never be given a design job. Okay, great. And I'll be the first one to raise my hand. Brian Paxson, over to you. You had a good question.
Yeah, and sorry, my my webcam isn't working right now, but and this was actually on my mind literally last night. Do you know why in Erlang it was decided to go with a simple implementation of pattern matching versus a more complex implementation such as what exists in Prolog? And further, was that decision based on you know, being able to be concurrent?
I think that's a question for you, Robert.
Yeah, no. The problem with unification in Prolog is that you need logical variables. You got variables on both sides, right? And when you unify, you'll be binding things on both sides. There's no sort of feeling of expression and pattern in that sense. And one of the things we discovered was we did not want logical variables because they cause problems. We found when we had the Prolog version that we hadn't intended it, but you could, in a message from one process to another, you could send a logical variable. And then the receiving process could then bind that variable and send data back, right? And we didn't want that. We wanted all the communication to be extremely explicit. So that's why one of the things we want to do is remove logical variables. And then you can't really do unification. I love it. I love Prolog. I think Prolog is a fantastic language, but there were just things in Prolog we just didn't want. And logical variables is one of them.
Very interesting. So I think if you could summarize it, it would be, we wanted to keep things simple and explicit.
Keep things simple and explicit.
Love it.
So
thanks, Rob.
That's for example, I'm just broadening here. That's one reason why the macro package is so basic as it is. It's just macros are fantastic. I'm a Lisp programmer like Bjarne. I love Lisp, right? But with Lisp macros, you can do an awful lot of stuff. You have absolutely no idea what's going on behind, and we didn't really want that.
Okay.
But Robert, you remember that one reason that you gave up Prolog for Erlang was that you couldn't do backtracking over hardware. If you sent out the rig signal, you can't sort of take it.
Yeah, you could get interesting effects doing that. You could actually do it if you really wanted to, but no, that was not a problem. The backtracking.
Okay.
Great. But I think
we've got
this example that you mentioned is it's very interesting to see how we combine the two programming traditions, because there is the message reception, but the way that, but then it to differentiate between different sort of signals, you use message pattern recognition.
Yeah, it's that was, I think, something we got right, was the use of pattern matching in as many places as possible. It's nice.
We have one last question. We're already over quite a bit, and I'll be told off. But we've got Daniel Kansas had a really good question as well. Over to you, and then we will have to wrap it up.
Yep. Hello. Sorry for being in bed, but I have some spine problems. I would like to ask, did you know at the moment of creating Erlang that it will be used so widely in telecommunications that it will be such a success?
No, I think part of this is just luck. In the old telecom systems, you would have requirements that that the system would be reliable, etc., and distributed, and those requirements were very peculiar at that time. It would be only telecom systems that would have that type of requirements. But today, with internet, That's nonetheless become sort of standard for all sorts of applications that were very peculiar at one time.
Mm.
But then we had the very good thing, and that's open source. We got stuck in the problem that if Ericsson wanted to use Erlang, they wanted it to be used outside so they could have trained programmers. And if somebody to use it outside, it would need to be used inside Ericsson. It was a catch-22. And the key to solve that was open source.
Yeah.
And
I just had one.
Yeah, go ahead, Robert. Yeah, and then we
I
really
just
need to wrap
had
up.
one comment on what Bjarne started saying. It was partially luck. I mean, there are a lot of programming languages that developed. A lot of them are very good. Some of them, many of them, just never get anywhere, right? And we had luck. We had support from some very good people higher up in the company that helped us survive and spread our ideas and things like this for it. But it was a lot of luck for it. And we were lucky in getting some projects using it that worked, right? The project produced products that worked. And nothing speaks better than a successful product.